Software engineers have many different types of caches at their disposal, each with their own use case and strategy. This video will cover what the negative cache is. To understand the negative cache, we first have to understand what a cache is. So, what is a cache? This is a simplified demonstration of what a modern software application does when it processes a request. The client makes a request to retrieve some information from the server processes that request, and then sends it back to the client. Oftentimes, the server needs to reference a database or a different system entirely to have the necessary information to process the client's request. Each request a server makes to other systems drastically increases the total processing time and is often the slowest part of processing a request. Let's look at a real-world use case. When I go shopping for items for sale near me, I want to know the rating of the seller I'm purchasing from. Never again will I buy something from someone with a 2-star rating, no matter how cheap it is. In this system, the local sales service returns all the items for sale near the client and includes the rating of each seller. Local sales service first reads all items for sale from the database, but seller rating service stores the seller rating, so it needs to communicate with that service before returning the results to the client. It can be a slow process to retrieve the seller rating because each item from the database translates to a unique network request made to the seller rating service. Now, these calls can be made asynchronously, but it's still a slow process because network requests are being made. Sometimes the request fails. This could be something transient, like a networking issue, or it could be an issue with the service. What should local sales service do when one of the seller ratings can't be retrieved from seller rating service? One option is to retry the request a few times. The idea is maybe the request will work the next time. The downside to this is extra time is spent waiting to compute the result. A second option is to not include that seller's item in the response back to the client. The client doesn't see any items for sale until they get the response back. That means when time is spent retrying, they are not seeing anything. By ignoring the problematic items, they still see items for sale, but they see them much faster. Any product that fails to get a seller rating will not be included in the result. That was a lot about requests, retries, and failure modes, but how do caches fit into the picture? As we saw earlier, a bottleneck is waiting for the response from seller rating service. It takes a long time to get all of the results because a network call needs to be made. Using a cache to store a copy of the seller rating information within local sales service will save time waiting on retrieving the seller's rating. Then, seller rating service is only called when local sales service does not know the rating of a seller. The cache only stores the result for a short period of time, so the items will need to be recalculated from time to time. In some cases, all of the items for sale will have cached values, so no requests are made to seller rating service. This is the best case scenario. So, what's a negative cache? A negative cache starts out as a regular cache, but over time becomes angry and has a bad attitude, which is why it's negative. I'm just kidding. Let's see what a negative cache actually is. The purpose of a negative cache is to store the errors in the cache. When an error is encountered, the error is stored in the cache, so future requests don't waste time asking for a value that can't be computed right now. The key characteristic of a negative cache is caching an error. Let's see what a full request looks like when all ratings are cached. Local sales service checks if it recently encountered an error with the seller. If so, then it can skip the call to seller rating service. The power of the negative cache is it further reduces network requests, specifically for those that are known to be problematic. Let's see some code for using a negative cache. When retrieving the rating for a seller, we'll first see if the cache already has it. If so, we can just return that. Otherwise, we'll go and compute the value and put that value in the cache. If there are any errors when computing the value, we'll store a special error flag in the cache for that seller instead of the real value. This special error flag is what makes the cache a negative cache. Now let's see how to use the cache within the service. We'll first get all the items for sale from our database. Then for each item, we'll go and compute the seller's rating. Any ratings that resulted in errors will not be included in the final result. Now let's see a negative cache in the real world. Amazon's DynamoDB database offers a caching feature called DAX. According to the documentation, DAX supports a negative cache. Whenever an item can't be found, an empty result is stored instead of generating an error. Where else have you seen negative caches? Let me know in the comments below, and thank you for watching.